Caitlin, and I'm back again with my final project video. So this here is the working product, and so this is a self-designed knee brace that measures two main statistics about a person's knee while they're doing physical exercise such as squatting and jumping. The first thing it measures is the person's angle of their knee, and it also measures the angular velocity of their knee. And so it measures the angle two ways. The first way is this homemade bend sensor that effectively measures the resistance that goes through this sensor, and then with an algorithm it transforms that into the angle of the person's knee. However, that angle isn't too accurate since the resistance is constantly changing. But what it does do is it's connected to a buzzer that goes off once the person's knee bends past a certain angle, which is just a preset of how much the resistance is. So once it exceeds a certain amount of resistance, the buzzer goes off, and it doesn't turn off until the person rights their knee again so that the knee is directly over the foot. It also measures the angle in a far more accurate way with the accelerometer. So this accelerometer, it has code that goes into processing for people who like to see visual data, and so it's basically a collection of lines, and one of the lines measures the angle past 90 degrees, and it tells them. And so when they squat and they see a divot in this particular line, they know that they're buckling their knee and that they should straighten it out. The other thing that this accelerometer does is it measures the angular velocity of the knee, which is very helpful for when someone cuts. Biomechanically, there's a specific way that you, when you play a sport, should be cutting, and that's you plant your foot and then both your knee and your hip rotate at the same time. What happens is that this can differentiate between when someone's doing that and when someone plants their foot, rotates their knee, and then rotates their hips. Because when they do this, they create unnecessary torque on the knee, which can result in torn ligaments and strains and things like that. And so the data actually can show when someone cuts correctly versus incorrectly. I say my biggest problem with this was getting it to be wireless. So when they send you a Bluetooth module, they pretty much don't give you any how-to on how to set it up. So for me, it was essentially figuring out how to correctly set up the pins so that the data was being received and transmitted correctly, and then figuring out how to get that data, because I knew that was being sent to my computer. However, I didn't really get how to access the data and do something with it. For my next steps, I'm planning on creating a pressure sensor for your foot. So basically what it would do is if you're squatting or jumping or something like that, it would show you exactly where the pressure is on your foot, because, for example, if you have too much pressure on the inside of your foot, it creates unnecessary stress on your knee. It does this by operating on the same principle as this bend sensor. It's essentially a bunch of conductive thread that's being run through, and it connects to another series of conductive thread, and in between there's velostat, and so you pump electricity through this, and it gives you a resistance reading. And so I would use processing to graph the amount of resistance in each individual section, and that would create a rough outline of your foot. So as you see, I've already tried to build this. However, I've run into some technical issues. One is with conductive thread, it's very easy to short circuit if separate parts of the thread overlap that aren't supposed to overlap, which is what happened because I did not plan this out very well whatsoever. And the other issue is that with processing and also with the Arduino IDE, it's going to be setting up the pins correctly because I didn't set them up correctly. So when I'd run a sketch in processing, certain parts of the sensor would work, but other parts wouldn't. So I'd say that those are my next steps, especially that troubleshooting, and obviously I'd like to make it more aesthetically appealing because no one likes a mass of wires. So that's it, and thank you for watching.